Hey folks, just thought I'd give you a little bit of assistance here as you're planning on your post labs. So real quickly, I'm going to include an article link for you as well to kind of get you started. But let's take a look at what makes up gelatin, which is the protein collagen. So if we take a look here and I draw three strands like this, okay, this would be an example of collagen. So you could see, if I hold down here, that you could have three separate strands of proteins. Okay, so this would be like the primary structure, which is just a line of amino acids. And then as they're coiled about each other, okay, these would be helices, you get secondary and tertiary structures. And this is, a collagen is found in connective tissues all over the body, in bones, in all the connective tissues, and we make gelatin from, sorry, but grinding up the connective tissues, hooves and skin and whatnot from animals, cows, pigs, etc. And we extract the collagen. Now, why is it that we use the collagen here? So let's go to the next slide. All right. So when we heat collagen, well, first of all, let's take a look real quickly at what holds collagen together. So if I take a couple strands here of the protein, like this, and let's go maybe one more like that. If you look in here, in the middle of it, there will be bonds that will keep these protein strands together. Okay? And they're linked together, weak bonds. Okay, so these are definitely that and that and that, etc., are weak bonds. But there's a lot of them, and so it's kind of like Velcro. It holds the protein together in this shape. And if you notice, the shape is kind of this spiral shape. It's an elastic protein. Collagen is very elastic. If you think about it, in the connective tissue, skin and tendons, and even in the muscle tissue, things that have to stretch and bounce back, you need this elasticity. So with the elasticity, these bonds hold the protein chains together, and the chains themselves provide the ability for these tissues to stretch and bend, blah, blah, blah. Okay, fine. So what happens when you put collagen into hot water? All right, so when you put collagen into hot water, what's going to happen is these strands are going to start to dissociate, right? Actually, I'll use this here. Let's use this guy. And if you notice the strands, this strand here will move out this way. This strand here will maybe stay here, and this strand here will kind of head out in this direction. And there are no more of those yellow bonds that bond this together. All right? So what we're left with is this heading that way, that heading that way, that heading that way, and they start to unravel. You still have this primary structure here, all right, and the primary structure that we're talking about is, you have the chains of amino acids. They haven't broken apart. They're still there. But the actual connectiveness of these three chains are starting to unravel because of heat. Okay? You're boiling it and you're unraveling it. Fine. So that's what causes the gelatin. That's why you have to add boiling water to gelatin. So when you do that, then you put the water, the boiling water, in the gelatin with your fruit juice or whatever else you're going to put in there, and then you add cold water. Add cold H2O. And as you add cold water and then put it in the refrigerator, what's going to happen is, and I'm just going to see, here are your strands again. You're going to get, like this, you're going to get, let's say the red are particles of flavoring, sugars and other kinds of things. And let's say now that the light blue is going to be water, okay, for example. And notice how all this stuff, and we'll go back to our yellow bonds, all this stuff it starts to get trapped together as these things start to relink. Okay, as you get these protein strands in collagen relinking, it traps these items in the collagen matrix. Plus, in addition to that, you get other collagen fibers out here that kind of start stretching across like this, in no particular order, and you get these linkages forming between them randomly, all over the place, linking these helixes that were once independent to each other, because you've unraveled it, and basically now that it's cooling, it forms a giant bird nest. And trapped in that big bird nest of collagen fibers are your sugar molecules and flavoring molecules and artificial or natural coloring molecules and all that kind of stuff that we add to gelatin to make it edible. Okay, and so what happens is you get all this stuff trapped in the middle, and the collagen wraps around it, and you get this lovely colloid structure with a jiggly texture. Okay, so that's what happens. But in order for that to work, these here, you've got to have these long strands of collagen. That's what it's based on. Okay, if you think about the analysis of a bird's nest, or a net, if you wrap long strands together, you get a net. You can't really do it with really short strands. It doesn't work so well. So what does bromelain and I think it's a ficane or whatever, several of the enzymes that you find in figs and pineapple, what do they do? And it shouldn't be clear to you that here are those, whoops, I didn't mean to, let's undo that. Let's go here, I'm going to go for blue. Okay. So you get these long strands, but then, and I'm going to go with orange. We're going to say orange is bromelain. And bromelain is going to hit on the protein. It's a protease. And a protease is a protein digesting enzyme. So when it hits there, you're going to get all along this area at certain sequences of amino acids. You can think of bromelain as being like scissors. So if I wanted to draw bromelain, another way to draw it might be like a pair of scissors. And everywhere that it decides to cut at certain amino acid sequences, okay, it's going to do so. And of course, that's going to result in a bunch of pieces, all right, of the original collagen, and your bromelains are still going to be here doing more cutting, but these pieces, even if a piece decides to interact or bond with another piece, it's not going to be enough to be able to trap the water and the sugar and the flavoring agents and all that kind of stuff, and so you're not going to get the nice gelled matrix. That only works with really long amino acid chains. Bromelain and the other enzymes found in certain fruits prevent that from happening, but they themselves, okay, can be affected, okay, whereas collagen was denatured by heat, okay, in its structure, okay, because these long strands were glued together with those weak bonds like Velcro. We denatured the structure of collagen, and then it sort of reconnected in a random fashion after we cooled it down. We can do the same thing to bromelain with heat, meaning if I take bromelain, and let's say this is a representation of bromelain as a protein, okay, we'll call it B. So there's bromelain. If I apply heat, okay, maybe boiling, to bromelain, what's going to happen is, just like the bonds, because actually if you look at bromelain, in bromelain, what's keeping it in this nice three-dimensional shape? Well, oddly enough, it's a bunch of those similar kinds of bonds that we thought holding it together in this nice 3D shape. Remember I said that shape was really important. So I heat it all up, and what happens is you get something like this, and it denatures. And so there's that word, denatured. And notice the primary structure is still there. Okay? You still have this big long amino acid chain. It hasn't been cut, but what happens is it's been unraveled. And when it's unraveled, for example, when you're pasteurizing pineapple products for canning or whatever, you destroy the functionality of the bromelain. And so even though the protein, the amino acid sequence is still in there, it's no longer able to be a protease enzyme, meaning like a little pair of scissors running around and cutting up other protein. Okay, so that's kind of the basis of what's going on here. In this little video here, I want to finish up that if you go to, oh, what does it see? There's the Learning channel, and what is the website here? It's a How Stuff Works. So if I can write that down here, looks like what do we have? Okay, so here's the website. Recipes dot how stuff, it's supposed to be stuff, works .com, and that's slash, and then I got to continue down the other line, J slash ELLO 3.htm. And it's several pages of an article that talks about collagen, what we just discussed. Okay, so that ought to get you started, at least, in the project, and email me if you have any questions. Hope it was helpful. Thanks.